Okay, did you copy that? All right, and you're a real ham. Kate BYP has made a horrifying mistake. I have made it for 40 years. I knew better, I knew the science behind it, and I still made it because I made the mistake that many of us do of learning more advanced concepts and not absolutely mastering the basic. And I just realized this literally a few weeks ago. There are tuned circuits of inductors and capacitors, and then there are circuits that are not tuned circuits. That is not a tuner. That is not a tuner. The consummate engineers at Drake said it's a matching network, not a tuner. That little toy there is not a tuner. I have 4 so-called tuners, and I don't use any of them because they have no business being on ham radio antenna systems. But that's another story. Words mean things, and their meaning is generally based on historical use. In the old days, 1920s or so, when they discovered the advantages of adding capacitors with inductors to make tuned circuits, then they could make a spark gap transmitter much more efficient. Because why? Because an LC circuit could be tuned to a frequency and discriminate against others. The spark gap problem is that it tries to transmit on every frequency that there is. If it's a square wave, then a square wave comprises an infinite series of harmonics mathematically. So an electrical arc in theory will generate 8 gigahertz. Well, good luck getting a useful energy, but in theory there it is. The top are tuned circuits, when their inductances, inductive and capacitive reactances, are equal and opposite. Pardon me coughing, I've been cleaning the HAMSHACK and it's dusty. But when those values are adjusted by an adjusting arrow, and the one on the right is the Drake TR3 and TR4 and the R4 and so on VFO mechanism. Permeability tuned, slug tuned. But when they are tuned, the implication is tuning a circuit to a frequency. The predominant use over the last 100 years has been, I tuned in the radio to radio station blah, blah, blah on some frequency. Turn on the tuner. What's a tuner do? Turn the big knob to tune in a station. Tune us in, the broadcasters say. Adjust your set to their frequency and not other frequencies. The resonant frequency is 1 over 2 pi square root of LC. When the components are at resonance, or their reactances are the same magnitude. Circuit on the left, series resonant circuit, approximately 0 impedance. Circuit on the right, approximately infinite impedance and nothing in between, unless there are losses. But these components on paper are from the Ideal Component Corporation. They have no losses. That there is not a tuned circuit. And that is what's in that merge. Actually, a little more complicated, but basically that's it. Series capacitors for DC isolation to the antenna jack and a shunt inductor, roller inductor. So that's the merge, more or less. Not a tuned circuit. At no time in that circuit, when it is properly operated, is there a resonance. Never, ever. And I haven't done a video yet. That's coming after this one, but I want to bring in the initial premises. But this is what's called a matching network. Says our experts at Drake. Matching network, not a tuner. Never say that's a tuner again, or your tongue will fall out. Its purpose, according to our expert Terman in the Radio Engineer's Handbook, is that each port on each end, terminal here, there, And there, each port has an image. The Terman calls it impedance. It is not. It's a resistance. It can only match resistive values at each port. That's an elementary ladder network. It is not tuned. Not. The goal of these are to tune to a frequency. And particularly the parallel resonant is very, very narrow banded. It's asymptotic. That's approximately what a quartz crystal is. And we say crystals select a frequency. The purpose of this, ideally, is to be infinitely broad-banded, but match a resistance value on either side. It is a transformer. It's not a wound transformer on a bobbin, but it doesn't have to be, because a wound transformer in circuit theory reduces to a T, actually with 3 inductances instead of 2 capacitors. But through the magic of ladder networks, that does resistance transform. And the way it does that is that to go from a high to a low resistance requires that this branch here, capacitor, inductor, and implying a resistor across here, the series combination of the capacitor and resistor put in parallel with that inductor has to do 2 things. This capacitor cannot do an impedance transform. All that can do is that. But the magic in these networks, these matching networks, is that this is a combination of a series and a parallel circuit, because a load resistor is in series with this. But this capacitor and that resistor, through a transform, are in parallel with that inductor. And thus, in this right side of the circuit with 3 components, there is a low impedance, or actually a low resistive arm. And that is in parallel with the inductor, which comprises a parallel circuit, but at no time is it resonant. If it were resonant, it would be an open circuit. And a transform from a 50 ohm output to a 2000 ohm input is accomplished by this right side, which leaves, analyzing from this point to the right, leaves a resistive value equal to the input with a reactance equal and opposite to this capacitive reactance. And that's what these Foster's resistive matching ladder networks do. While you're waiting on my next video to start to go into network theory, look up Foster, Ronald Foster, and also George A. Campbell, because we all know that radio was invented by the Scots. So, and so is copper wire. So, tuned circuit. The Drake TR3 has tune plate, tune grid coupling between the circuits. They have used 1930s technology of a parallel resonant tank on the grid, one on the plate, tune them to maximum for maximum receive strength or maximum transmit output. And contrary to the myth and the lies about harmonic antennas, as I mentioned in that video, engineers these days are representing tunings in an antenna as a series LC circuit. They are not. But that's what they do for mathematical convenience, because it appears that way, just as a crystal might appear to be a parallel resonant circuit, but is not. There's no circuit in a crystal. I have taken them apart. There's none. But this series and parallel resonant circuits have only one and one only response. These are first order. They're not linear. The inductor's linear. The capacitor is essentially a 1 over x function, which is a curve. But these are first order components. You take the derivative of a first order function. What do you get? Nothing. No derivative, no local minima or maxima, so no other responses other than fundamental. So forget the lie about harmonic antennas. It's a bald-faced lie. Somebody making crap up. These circuits, this circuit has a humped response. It's fairly broad. But these sections like this can be repeated in a ladder network. Boing, boing, boing. Look at the output of any modern ham radio transmitter. You'll find a ladder network like this, probably an 8-pole. But that circuit, if it's in a more complex form with more components, can have very complex responses, but they are not primarily intended for frequency response. They're intended to match a resistive to a resistive value, and then there are other frequency considerations, such as a bandpass filter. But like this, a more complex bandpass filter, which has maybe a broader square response than this circuit, still intends to have excuse me, the resistive transform within that passband. And the goal of filter design is to minimize ripples in that. Even a good filter might have 1/2, 2 or 3 dB of ripple, which is quite a bit. But that ripple's in a transfer function and ultimately means improper matching in one port or the other. So, tuned circuit, not a tuned circuit, and never, ever, ever again call that a tuner. Understand that people that call that a tuner have no idea what they're talking about. They're just repeating blindly. As the 99th monkey, there's 2 monkeys right there. As the 99th monkey repeating something they heard, but they have no idea what they're talking about. God bless them, they mean well, but this is ham radio, this ain't CB. We need to know these things because that's what amateur radio is all about. Next video after this, go into Foster's networks, how the resistive transforms work, ladder networks, images, all that stuff. One of the better sources for this is Radio Engineer's Handbook by Terman. If you're just a beginner, that's going to be over your head. Excuse me. It'll be over your head. Terman, in publishing a Radio Engineer's Handbook, intends a handbook for engineers, and if you're not one, the chapter's going to lose you. So, this is really simple stuff here. This gets so complicated that this was about all there was, this T network or pi network, until about the 1970s when computers came to be. Because the calculations for multipole filters are so complex, mere mortals can't do them by hand. They just turn into a nightmare. But that's part of the reason why vintage like this just uses simple networks like these. But modern radios, like the Yaesu hiding down there because the fans are noisy, use complications of that. But today we have the computer power to solve those, and we get normalized formulas and denormalization data to solve them. So 73 from the now clean HAMSHACK. If you haven't seen the floor in your HAMSHACK for 2 years, it's time to clean it. Did it?